Today we are going to keep working with some of the solving equations work that we started in the last lesson. So just to give some quick reminders, in the last lesson we introduced the idea that to solve an equation, or in other words, to figure out what the value of the variable is, we have to rearrange the equation so that the variable is by itself. The way that we can rearrange an equation is by undoing the operations in an equation, which we are allowed to do as long as we do things to both sides of the equation because we want to keep our equation balanced. So we're going to use that same idea today. So in the last lesson, you learned that you can undo adding by subtracting, and also the opposite, undo subtracting by adding, because adding and subtracting are what we call opposite or inverse operations. They undo each other. Today we're going to work a little bit with some one-step equations that have multiplying in them. So the opposite of multiplying is dividing. If you think about some of the fact families we were working with integers, multiplying and dividing are opposite operations. They undo each other. So the way we can undo multiplying is by dividing. So we can use division to rearrange the equation. The only thing we have to remember is that we don't want to knock our equation out of balance. So just like how when we add or subtract, we have to do that on both sides of the equation. If we divide to undo multiplying, we still have to do it on both sides of the equation. So it looks something like this. We're going to look at a couple of examples to get you up and running with this. So first of all, remember that when you have something like this, 3x, a number and a variable right next to each other in algebra, if there's no operation symbol between the number and the variable, then we assume we're multiplying. So 3x is really 3 times x. So since we're multiplying, we're trying to figure out what x is. So we want that x by itself. We want to rearrange the equation. But that means that we're going to have to deal with the fact that it's being multiplied by 3. So the way that we can undo the multiplying by 3 is to divide by 3. So x times 3 divided by 3, well, those are going to cancel each other out and just leave me with x. But if I divide one side of the equation, because I don't want to knock my equation out of balance, that means I also have to divide the other side. So on the other side, I'm going to have to do 15 divided by 3, which is 5. So that means that x equals 5. And I can plug it back in and check. So if I were to plug it back in to check my work and put this back in where the x is, 3 times 5 does equal 15. It checks out. So that means that that is a correct answer. So what is shown in blue here is what your work should look like when you're working on these equations. So we are dividing on both sides of the equation. The division doesn't just happen on one side. So it has to happen on one side to cancel out the multiplication, and it has to happen on the other side in order to keep the equation balanced. So you really are dividing in two places. When you're showing your work, it's really important that you show both places where you're dividing and not just one place or not at all. Then you wouldn't be showing your work at all. So work that is completely shown should have all of those blue parts. You should show the dividing on both sides and show what you get. So let's look at one more quick example. So you can work with negatives just like how you would work with positives, because we know the rules for multiplying and dividing with negatives. So in this problem, and again, it doesn't matter which side the x is on, whichever side it's on, we want to rearrange to get it by itself. So in this case, the x is over on this side, which is okay. And it is being multiplied by, this time, a negative 4. So since it's being multiplied by a negative 4, the way I would undo that multiplying is to divide by negative 4, and that's going to undo the multiplying and get the x by itself. But again, because I don't want to knock my equation out of balance, if I divide one side by negative 4, I have to divide the other side by the same thing. And notice that I literally wrote it out twice. You need to show that you're doing it on both sides. So on this side, I end up with 8 divided by negative 4. And we learned that if we have opposite signs, one positive and one negative, and we divide, we get a negative answer. So 8 divided by negative 4 would be negative 2. So I get negative 2 equal to x, or if you want to spin that around, it doesn't matter which way you write it, x equals negative 2. And again, if you want to check really quickly and see if you're right, if you take that and you drop it back into the original equation, I can test my work and see. So -4 times -2, well, negative times a negative makes a positive, so that's going to give me +8, which is exactly what it's supposed to give me. So I know that my answer of x equals -2 is the correct answer. So that checks out because it makes the equation work. So again, everything that's shown in blue, the dividing on both sides, and also what you get after you divide, should be shown on your page when you're showing your work. So that is how you deal with multiplying in an equation. You undo it by dividing both sides of the equation. And if you have negatives in there, that's okay. You can divide by a negative number, and then over here on the other side, just be careful with your rules for dividing negatives and use your rules for dividing negatives over there. So what you're going to try today is a little bit of practice specifically with this type of problem so that you can make sure that you're able to do the process accurately.